Today we will learn about the 2D Cartesian coordinate system. Have you ever used graph paper to draw a picture or to find where a point is? A coordinate system is like those grid lines. It helps us find exact positions using numbers. Long ago in Bharat, cities in the Sindhu-Saraswati civilization used neat grids, like an early coordinate system. Great thinkers here and elsewhere added ideas that help too. Bodhayana used straight north-south and east-west lines for geometry. Ujjaini was used as a central reference point. Aryabhata used signs to find positions, and Brahmagupta accepted zero and negative numbers. Later, René Descartes showed that any point on a flat plane can be fixed by two numbers, and that idea became the Cartesian plane. Now imagine two straight lines that cross each other at right angles on flat paper. The horizontal line is the x-axis and the vertical line is the y-axis. The point where they cross is the origin, written as open bracket 0, 0, close bracket. We mark equal units on both axes. Distances to the right or up are positive and to the left or down are negative. A point is written as p open bracket x, y close bracket. Here x, the abscissa, is the distance of the point from the y-axis measured along the x-axis, and y, the ordinate, is the distance from the x-axis measured along the y-axis. Special cases are easy. A point on the x-axis looks like open bracket x, 0 close bracket, and a point on the y-axis looks like open bracket 0, y close bracket. For example, if point P is 3 units to the left of the y-axis, its coordinates are open bracket -3, 0 close bracket. If C is open bracket -3, -2 close bracket, its distance from the x-axis is 2 units and from the y-axis is 3 units. If D is open bracket 2, 1 close bracket, its distance from the x-axis is 1 unit and from the y-axis is 2 units. Note an important rule. If x equals y, then open bracket x, y close bracket is the same as open bracket y, x close bracket. But if x is not equal to y, they are different. The axes divide the plane into 4 parts called quadrants, numbered 1 to 4, anti-clockwise from the top right. In quadrant 1, both coordinates are positive. In 2, x is negative, y is positive. In 3, both are negative. And in 4, x is positive, y is negative. For practice, open bracket -2, -4 close bracket lies in quadrant 3, open bracket 1, -4 close bracket lies in quadrant 4, and open bracket -3, 2 close bracket lies in quadrant 2. To find distance between 2 points, we make a right triangle and use the Bodhayana-Pythagoras idea. If A is open bracket x1, y1 close bracket and B is open bracket x2, y2 close bracket, the distance equals the square root of open bracket x2 minus x1 close bracket squared plus open bracket y2 minus y1 close bracket squared. For example, A open bracket 2, 3 close bracket and B open bracket 5, 7 close bracket give differences 3 and 4. 3 squared plus 4 squared is 9 plus 16 equals 25. Square root of 25 is 5 units. This formula treats plus or minus the same way because we square the differences. So reflections keep lengths the same. Special short cases. If 2 points share the same y, distance is absolute value of x2 minus x1. And if they share the same x, distance is absolute value of y2 minus y1. So, what do we learn from this? The coordinate plane lets us find any point with two numbers, tells us which quadrant a point is in, and gives a clear way to find distances between points. Let us quickly remember. Axes are x and y. Origin is open bracket 0, 0, close bracket. Points are open bracket x, y, close bracket. Quadrant signs tell plus or minus, and distance uses the square root of squared differences. Keep exploring these ideas with graph paper and simple points, and you will soon feel confident plotting and measuring. Good job today! Keep your curiosity alive, and if you want more practice, explore similar lessons on EduRev in a calm, steady way.